So here we are, we're looking at question 11. It says, for what value on C, on 0 to 1, is the tangent to the graph of f of x equals e to the x minus x squared parallel to the secant line? So first of all, based on this terminology here, we should have figured out what the question was really asking us about. So we're looking for basically a theorem here that we've been dealing with, right? That involves C, a closed interval, and a secant line parallel to some tangent line. So if you guessed it, this is the mean value theorem. And what does the mean value theorem say? It says that at some point C between the interval a to b and C is contained in a to b, this instantaneous rate of change of C, f at C is equal to the average value from A to B, i.e. the secant line is equal to the tangent line. Okay? So we just have to use this information now. So it's basically asking you to find C. So what do we have to do? We have to set, what this is basically saying is set the derivative equal to the average rate of change. And remember, the derivative is the instantaneous rate of change. So the derivative is going to be equal to the average. So I think the easiest thing is probably to find the average, this thing over here first. So you know this is A and this is B. It's pretty obvious. And we already have F, so we're going to plug it in. So the mean value theorem here, I'm going to be using this one here, and we'll just go off to the side here. Ready? So I know I'm going to be doing this part here. So F of B, B is 1, so it's F of 1 minus F of 0 over 1 minus 0. Okay? And remember, f is just this function, so I'm going to be plugging them in here. Okay? So this is e to the 1 minus 1 squared minus, parentheses, e to the 0 minus 0 squared. Note, all I did was I plugged them into the function f all over 1. So simplifying this gives me e minus 1. This is e to the 1, e to the 0 is 1, right? And that's just 0, so this is just 1, so it's minus 1 here, okay? And then all over 1, so this is e to the minus 2 over 1, which is clearly just e minus 2, right? So this here is this piece. So now we just have to set it equal to the derivative. So the derivative of what? Of f of x, which is given here. So we know that f of x is e to the x minus x squared. So f prime of x is e to the x minus 2x. Okay? And now we just set the derivative equal to the average, which was this guy here. So you might be looking at this and you're like, I have no idea how to solve this problem. It's kind of scary here. Like, what do you do, right? So you, at this stage, don't worry, because you want to find x. This is difficult because this is what we call a transcendental equation. You can't solve it by hand. It's very complex to do so. So we're going to use your calculator. Okay? How do I do so? First, you want to go ahead and set it equal to 0. Okay? So, and then we're going to find the zeros of that. So I'm going to minus e and add 2 to both sides. So if I do that, minus e and plus 2, I get e to the x minus 2x minus e plus 2 equals 0. I just moved this stuff over here. And now we're going to use our calculator and find the zeros of this one here. I'm going to go to y equals, I'm going to put it in. So what is it? It's e to the x. If you don't know where e is, so we go to second, and then go to ln. If you see here, zoom in. Right next to number 4 is ln. And then if you hit second, you see a little e to the x, and then e to the x should pop up here. And we're doing e to the x here, minus 2x, minus e. Now e, you just go e to the 1. So hit second again, and then you're going to go to ln. and then it's going to go E, and then just put a 1 in there, in close parentheses, and then go, what is it, plus 2, right? Plus 2. So make sure you have this one here, and then let's hit graph. I don't know what kind of picture we're going to pop up here. It may be difficult to see. So we want to find the 0. So the 0 is where it touches the x-axis, so we need to zoom in. So let's go to zoom. So you hit zoom here. And now we're going to go to, and we're just going to zoom in. So let's go to zoom in. And then, where do you want to zoom in? I need to zoom in like where I think it's 0. Let's try here. Okay, is this a better picture for us? Yes, it is. It looks like there's 2 values because it goes underneath the x-axis and comes back up. So we're going to find the 2 zeros here. If you want, you can zoom in even further. I'm just going to do this just for fun. Okay. So here we go. And now it's just really clear. And I have a very clear idea about where my 2 answers are, right? And if you can see here, you can even just start to approximate based off of this here. You know, one of them is less than 1, and you know one of them is greater than 1. And clearly they're both not negative because they were both on the right side of 0, so A is clearly wrong. So it's probably B, because it's a little further than 0.3, but we'll get a perspective here. So let's find one here. So we're going to find the 0, so go second trace, go to 0, and you're going to go here, and you're going to go to the left of 0, so take your cursor. Okay, right now I'm at 0. So first bring it to 0, and now go to the left of 0. Just go to the left of it a little bit, and hit the enter button. After you do that, it's going to say, go to the right of 0 now. So go to the right of 0. Notice, using my arrows here, I'm just going to the right of 0. And then just hit enter. And then when it says guess, just go ahead and go back to the center and just hit guess. And it should give you the following here. And so x is, I'm going to write it off to the side, approximately 0.351. Right? There you go. Oops. And I think that's the only answer that seems to make sense here, because that is the only answer that is less than 1. And for some reason, I negated or neglected to put on this one. Oh wait, never mind. If we remember, I only wanted on this interval here, 0 to 1. And so clearly the only answer between there was this one here that I found. So thus the answer must be B here.